Here we want to do what's called power series representation of a function f of x. So recall that a geometric series has a infinite series of this form. And remember that this geometric series, it converges to a divided by 1 minus r, as long as r, the common ratio, is between negative 1 and 1, and r is the first term. And so, for example, if we have this geometric series where n starts at 0 of 2 times 1/3 to the n, then if we expand the series, this is what it looks like. And this is the first term, so this is a. So a would be 2 times 1/3 to the 0, and 1/3 to the 0 is 1. So 2 times 1 is 2. The common ratio is 1/3. And so r is between negative 1 and 1. Therefore, this geometric series converges to a divided by 1 minus r. In this case, a is 2, r is 1/3, 2 divided by 2/3 is 3. So this geometric series converges to 3. And here's another example. So here we have the geometric series of 4 times 1/5 to the n. And if we expand it, we get 4 times 1/5 to the 0, since n starts at 0. And then to the first, the second, and so on. So a is the first term, so this is the first term. 4 times 1/5 to the 0 is 4 times 1, which is 4. And then the common ratio is 1/5. And therefore this geometric series converges to a divided by 1 minus r. a is 4, r is 1/5. So we have 4 divided by 1 minus 1/5, which is 5. Here we have another geometric series. This time it's just 1/6 to the n. It also n starts at 0. So expanding the series, we get 1/6 to the 0, 1/6 to the first, and so on. The first term, that's a, so it's 1/6 to the 0, which is 1. And then the common ratio is 1/6. And since common ratio is between negative 1 and 1, this geometric series converges to a divided by 1 minus r. So we have 1 dividing by 1 minus 1/6, which is 1 dividing by 5/6, and so we get 6 over 5. Therefore, this geometric series converges to 6 over 5. And now what we're going to do is we're going to do the reverse. What if we're given something that looks like a divided by 1 minus r, and then we want to write the corresponding geometric infinite series. So here we were given the geometric series, and we found a divided by 1 minus r. And now we're going to do the reverse. Given a divided by 1 minus r, then how do we find the corresponding geometric series? So here we have the function 1 divided by 7 minus x. And so this looks like the form of a divided by 1 minus r, similar. And then what we want to do is find a geometric power series that would represent this function for values of x around 0. And so we're given that, so this is what we're given. We're given a divided by 1 minus r, and what we're trying to do is find the geometric series that corresponds to what's given. And so in order to And so first we need to find A and we need to find R. Now A can vary, R can vary, but the 1 here is fixed. And so what we have to do is transform this part right here, meaning make this thing right here 1, because it has to be a 1 right here. And so in order to make this number right here become a 1, what we can do is divide everything on the top by 7, divide everything on the bottom by 7. So here we get 1, 7, and then 7 dividing by 7 is 1, and then x dividing by 7 is x over 7. And so now this is in the form of A dividing by 1 minus R, and specifically 8 is 1/7, and R is x over 7. So A is 1/7, and then and then R is x over 7. And so now that we have A divided by 1 minus R, and then we can write this series this geometric series right here. In the place of A, we would put 1/7, and then in the place of R, we would put x over 7. And then this is what it looks like. So in the place of A, we have 1/7. In the place of R, the common ratio, we have x over 7. So the function 1 dividing by 7 minus x is the same as 1 over the same as the geometric series of 1 over 7 times x over 7 to the n. And then notice that because this is a geometric series, it converges if R is between -1 and 1. So remember that geometric series converges when R is between -1 and 1. But in this case, R is x over 7. And therefore, this series right here converges if x over 7 is between -1 and 1, because R is x over 7. So we have -1 less than x over 7 less than 1. Multiply everything by 7, then we get 7, -7, and we get x to be between -7 and 7. And so what this means is this: if x is any number between -7 and 7, and then this function and this power series are the same. So this is called a power series representation of the function 1 dividing by 7 minus x. And so now let's pick the number between -7 and 7 so we can see that they're the same. So let's pick 2. 2 is inside of in the interval between the -7 and 7. When x is 2, then we get 1. For the function, we get 1 dividing by 7 minus 2, which is 1/5. And for the power series, when x is 2, so we put a 2 right here, and we know that this is a geometric series. And it converges to A divided by 1 minus R. And so 8 is 1/7, R is now 2/7, because x is 2. So we have 1/7 dividing by 1 minus 2/7, which comes out to be 1/5. And so for the function, we get 1/5. For the geometric power series, we get 1/5. And so one more time, This geometric power series is called a power series representation of the function f of x equal to 1 dividing by 7 minus x.